In this video, let us see how to write the Verilog code for a NOT gate using data flow modeling. So see here, this is the syntax: module name. So what is the module name means? NOT underscore gate is called as module name. Next comes port list. So here y comma a comma b is called as port list. After that we have to do port declaration. Port declaration means what are the inputs and what are the outputs that I am using. So here among this port list I have taken something wrong in order to show you what kind of errors do we get. So here if you observe, NOT gate contains only one input and one output. So here y is output, a is input. So no need of writing this particular b. Okay, you can observe here only one input is there. So that's why you can remove this one also. Okay, module name and port list, output is y, input is a. Next, as I am writing the code in data flow modeling, so I have to use continuous assignment statement here. So for that the keyword is assign. So assign y is equal to complement a. So this is the symbol that I am going to use. Okay, rest everything will be same. So let us implement the same using Xilinx. Click on ISC Design Suite 14.7. Click on File, New Project, and Name. So the name that I am giving is NOT underscore data flow modeling. Next, click on next and finish. So first I have to write the source code. So for that, right click on this, new source, Verilog module, file name. File name is NOT underscore data flow modeling. Click on next and finish. So here I have to write the code. So here module, this is module name, NOT underscore data flow modeling. And what is the port list? It contains one output y and one input a. So next we have to do port declaration. So among this, output is y, input coming to input is a. Next, as I am writing the code using data flow modeling. So in data flow modeling, continuous assignment statement should be used. So the keyword for this is assign. So assign, directly you can use a boolean expression. So boolean expression is y is equal to complement of a. Done. Next, it will be end module. Save it, try to synthesize and see if there are any errors. So synthesis completed successfully. You can view the RTL schematic by double clicking on this. So NOT underscore data flow modeling is a module name that I have given. Double click on it to view the internals and view technology schematic, NOT data flow modeling. So here IBUF stands for input buffer, OBUF stands for output buffer. Next, let us see whether it is working fine or not by writing a test bench. So in order to write the test bench, right click, new source, Verilog text fixture, file name we have to give. So the name that I am giving is NOT underscore data flow modeling underscore test bench. Next and finish. So here if you observe, module followed by name, and inputs will be treated as registers, output will be treated as wires. Next we have to instantiate the unit under test, means for what particular module that I am writing the code. So I am writing the code for NOT in data flow modeling. So that's why I am going back to the source code and I am copying this first line and place it here. Either you can use directly this one also, no issue. This is called as ANSI style of declaring. This one also you can use, or else directly you can replace it with the code that you have written in source code. So here name that I am giving is NOT gate. Next, after initial, begin and end will be there. So between this you have to give the test vectors. So first test vector is a is equal to 0. After 100 nanoseconds of delay, a will be 1. Okay, if you want to view the result in console window, add a $monitor statement. So $monitor. So $monitor will monitor the continuous changes in the variables. So next, dollar time. Dollar time is used to print the simulation time. So I want to monitor y is equal to percentile b, means I want to monitor y. Here percentile b means some binary value. Next, a is equal to percentile b. It is same as C language, so outputs are y, inputs are a. Save it and go to design window, choose simulation, select your test bench, elaborate ICM simulator, double click on behavioral check syntax. Okay, it is working fine. Next, click on simulate behavioral model. So I got some waveform, so let us verify whether it is correct. So if you observe here, when input a is equal to 0, output y is equal to 1, so complement. Next, when input a is equal to 1, y is equal to 0, so it is also a complement. So working fine. So the same result you can view it here in the form of text within the console window. So here 0 and 100 indicates simulation time. If you want to view the simulation time, then you have to use $time in your test bench. I hope you have understood what I have taught. If you really liked my channel, please subscribe to my channel. Thank you.